Good afternoon, everyone. Thank you for coming. Before we begin, I wish to acknowledge the traditional owners and custodians of the Georges River, the people of the Eora, Darug, and Darwal nations, and pay respect to their elders, past, present, and emerging. Today's webinar is part of the Get the Site Right campaign, a collaboration between the Parramatta River Catchment Group, Cooks River Alliance, Georges Riverkeeper, Sydney Coastal Councils Group, Lake Macquarie Council, New South Wales Environment Protection Authority, the Department of Planning, Industry and Environment, and many Sydney councils. We're working together to target developers and enforce best practice on commercial and residential building sites, as well as major infrastructure projects to protect our waterways and surrounding environments. The amount of sediment runoff generated by construction sites is commonly 100 times greater than from agricultural land. Sediment runoff can have a significant negative impact on waterways, causing pollution, habitat loss, fish kills, weed spread, and other serious issues. Sediment runoff can be reduced and prevented to give us cleaner, safer, and more scenic creeks, rivers, and other waterways. Join us for the short webinar to find out more about the environmental impacts of sediment runoff on our waterways and why we work with councils and why councils do the work they do to ensure buildings and construction sites have effective erosion sediment controls in place, and why that is so important. So our presenter today is Marion Huxley. She's the aquatic ecologist here at Georges Riverkeeper. Marion has more than 17 years experience in ecology, during which time she has gained an extensive understanding of scientific design and data collection. She has undertaken a range of field surveys, including assessments of land use, riparian flora, and aquatic flora and fauna. She has also identified a variety of macroinvertebrates, fish, and frog species. Marion is passionate about environmental conservation. Today, after Marion's presentation, there'll be time for questions, so please hold your questions to the end and use the chat function to write your questions down during and after the presentation. Also, just to note that the meeting is going to be recorded so that we can put it up on the website later for people to watch who weren't able to come this time. So I'll hand over to you, Marion.
Thank you very much, Beth. Just share my screen with you guys. Sorry about the sunlight in my face. I've tried to block it out, but it's like a natural spotlighting, I suppose. So, clogging up our creeks. Well, you know about sediment and how to control it. But why do we do it? What are the impacts? Why do we care about sediment controls? So what's the problem? Sediment control is really water control. We are trying to slow down the power of water to prevent sediment travelling with it. This picture is a plume from the recent floods in Sydney to give you an idea of sediment movement. As you can see, sediment was forced out along the Hawkesbury-Nepean River into the ocean, causing a massive plume. Impervious surfaces in urban areas such as roads, footpaths, and bare earth, like you see on construction sites a lot, has exacerbated storm and rainfall events. Water is not absorbed into the earth naturally, like it is in vegetated and forested areas. So more and water is, and sediment travels with it and forced into the rivers and creeks, and eventually the oceans. There are the obvious physical impacts of sediment, like choking of infrastructure. Here we can see the problem in pipes and drains. Well, the same thing happens in waterways, really. Fine sediment can directly choke animals like fish, shellfish, crustacea, and bugs, eventually suffocating them. It also impacts important habitats like seagrass, fish nurseries, and bug habitats. A main impact is the shallowing waterways causes the levels of dissolved oxygen to plummet. One of the most dramatic ways and devastating effects of low oxygen are mass fish kills, which have gained public exposure in Australia in the past few years, unfortunately. Last year, thousands of fish were killed in the Macquarie River near Dubbo. Rain washed sediment into the river, causing dissolved oxygen levels to drop rapidly and causing mass fish death. The dissolved oxygen levels were just 25% of what native fish require to be healthy and to survive. Large Murray cod, estimated up to be 30 years old, yellow-bellied, threatened catfish, and even the usually unkillable carp were decimated. Last year, there was a fish kill at Griffith in Lake Wyangan. The council had piped 242 megalitres into the lake over 6 days to prevent future fish kills. But there was also a storm water event which contributed several hundred megalitres of water and caused an influx of sulfic sediments into the lake. Thousands of native fish died in this event, including bony bream, golden perch, silver perch, and again the Murray cod. And of course, we all heard about what happened in Menindee Lakes, where there was a massive suffocation of fish in 2019. Most of the time, fish kills are a result of multiple factors, and the deleterious parameters contributing to a devastating drop in water quality. Put simply, if you're a fish, you rely on the dissolved oxygen in the water to breathe through your gills. When your lake or creek fills up with sediment and gets shallower, you struggle to breathe. Silt may clog your gills, and the turbid, muddy water may cause you to choke, as you can't get enough oxygen out of the water. Like most things in nature, sediment is a balance. Of course, plants and animals require some sediment to create homes, a place to lay eggs, and to raise their young, and to hide from predators. The death of fish fry and eggs has a massive impact on the predatory species, as does the destruction of insect larvae that often live in fresh water. Fish nurseries like seagrass can be choked or overwhelmed and cause major disruptions to flora and fauna life cycles. Dugongs like eating lots and lots of seagrass too. Here's a picture of food chain. If a key in the food chain is removed, for example, the bugs or macroinvertebrates, like seen here, caddisflies, stoneflies, midges and mayflies, if they die, it has a domino effect on the food chain within a river. Macroinvertebrates or bugs require specific habitats and sediments types to survive. If there's too much sediment or turbidity, the animals are eradicated because of loss of habitat or food, which will go on to affect the food chain. As this diagram shows, it affects predatory fish and even water birds as they struggle to find food. The effects on aquatic animal life is far-reaching. Fish are obviously affected, but yabbies, freshwater crays, and even aquatic mammals such as rats, bats, and platypus who rely heavily on bugs for their food source. And also the fly fishermen who use the rivers to catch fish, of course. Secondary effects of sedimentation are invasive species like carp, who can survive in more polluted streams with lower dissolved oxygen levels and don't mind a bit of muddy water. There is an old Chinese proverb, you catch more fish in muddy water, which is certainly true when it comes to carp. The consequences of this is carp get to breed another generation, while the native fish die out. Carp outcompete other fish and animals by eating all the small fish and bugs. They also take up valuable habitat that may otherwise be occupied by native fish species. The runoff which comes from impervious surfaces can cause mass erosion and bring plenty of nasties with it. Sediments often pick up nutrients such as phosphorus and nitrogen from fertilizers and sewage. This combined with diminished oxygen levels in the water contributes to algal blooms. The inflows of silt and nutrients carried by water and sediment can cause a spike in bacteria as well. This is a photo of the brick pits at Sydney Olympic Park recently, just to show you the effects of runoff and lack of oxygen. This section in the corner here is where you can actually see the water, that black bit. This area has an aerator, so you can see where the dissolved oxygen is increased and the algae has actually died off. Weeds are a big problem from sediment and runoff. Weeds can attach themselves to sediment and can be washed down into different creeks. Or flooding can cause sediment weeds to encroach on waterways which used to be healthy and pristine because they weren't seen there previously. As I said before, there are many parameters which contribute deleterious effects to water quality. Frogbit was discovered in the upper reaches of the Georges River in 2019, which may have escaped from a backyard pond or aquarium. Frogbit is a fast-growing floating weed that forms large, dense mats across the water's surface and prevents native water plants from growing. Frogbit reduces light, food and shelter for fish and other aquatic animals and can choke waterways. Diseases such as chytrid fungus is spread through infected frogs, soil and waterways. Chytrid disease is devastating with fungus, which causes frogs to become very ill. Their skin starts to slough off and they lose their appetite and look generally lackluster and depressed. As you can see, this is a healthy great barred frog, and this is a frog in the later stage of chytrid disease. When floods occur, things like invasive species, diseases, and weeds can migrate to different pools and waterways, causing infestation in otherwise pristine areas. There are plenty of diseases and pollutants which spread in sediment and waterways, many of which also affect humans. So what can we do? Minnehaha Falls is a great example of what to do. Minnehaha Falls is a waterfall in the Blue Mountains. But decades of urban stormwater runoff resulted in the decline of water quality, a loss of habitat and aquatic biodiversity, and sediment started filling the local swimming hole. This is a picture of Minnehaha Falls in 2006. There was a legend from the locals about a bottomless pool here, but as you can see, it is full of sediment. A bush care catchment group was formed and they assisted council to transition towards a water-sensitive city. Works were undertaken to conserve local ecological communities and species in the catchment. Bushland restoration works were designed and carried out systematically in order to improve habitat connectivity and wildlife corridors. Works focused on bank stabilisation and the restoration of pools and riffles. This all had an effect to improve in-stream habitat and enhance aquatic biodiversity. Council worked across the community to restore the creek, and after 10 years, the bottomless plunge pool had been returned, swimmable once more. As you can see in this photo, in the 60s, it was free as sediment, and the legend of it being a bottomless pool was established. Then in 2006, it had become a fat and full of sediment. Then it went on a diet, and the waterfall naturally scoured the waterhole out to become a deep swimming hole. So they're the before and after shots, and in between, I suppose. So now the pool is so deep, you can jump off the falls into it if you're game. According to the councillor who made a lot of this happen, Jeffrey Smith, the only problem now is getting into the pool is it's full of tourists and backpackers. This project won many awards and the benefits are really obvious. So how did they do it exactly? Well, here's a list of the main things the community and council did. I won't go into them all, but here's some highlights. 2 disused council quarries were rehabilitated. Council's depot was upgraded to include stormwater retention basins, an artificial wetland, and stabilised all unconsolidated sediment. There was an installation of 7 new stormwater quality improvement devices, or SQUIDs. 15 kilometres of unused trails closed and were rehabilitated. Illegal vehicle access to prevent damage from four-wheel drives. Over 12,000 hours of volunteer work was completed. Over 5,000 native species were planted in riparian zones. Over 250 catchment pledges signed by residents promising to implement actions. From 2008 to 2016, in-stream biodiversity improved significantly. There was a huge improvement in water quality, from the creek going from a score of B to A, which is a massive effort. So if these things can be achieved in Minnehaha Falls, and they certainly can be achieved in our catchment, although they take a lot of time, and as you can see, a lot of input from communities and organisations working together. Small actions over time has made a huge success in improving water quality, not just for animals, but also plants and for people. This is why it's really important to get the site right, as construction does contribute a massive amount of sediment inflow to waterways.